Okay, so this is our final submission for our tic-tac-toe game. You can see the game starting. So for this, we haven't done any changes to the robot. It still only has the one rotation of the X and the rest in the Y. We're still using the Pololu Maestro microcontroller and the Robix set for the servos themselves and all the nice metal brackets and your generic number pad that it's hitting right now. So as far as the game goes, you can see the game's complete. It's actually playing against us right now. The strategy that it's using is first it will check to see if it can win. So if there's two in a row, it will set the third. Or if it can't find that, then it will check to see if it can block us from winning. As you can see here, it's going to go ahead and place the X and block our O's. And if it can't do either of those, then we'll see if it can set a trap. And now what a trap is it's just checks to see if it can set its character anywhere so that the next turn it will have two spaces to complete the row or the set of three. And if it can't do that, it will see if it can block us from setting a trap. And if all of that fails, then it will just set a character in any empty spot. Okay, so as far as the moving of the robot itself, in C++ with the controller we're using, there was no built-in control for speed. It was only just set a position and have the servos jerk over there, which is why some of the motions are kind of jerky. So in order to get the slow movement, like the approach for the enter, because we didn't want to bash in the number pad and break it. So instead all we do is we use a for loop and have it slowly get closer to the position, to the destination position. Now as far as accuracy goes, you can see here when it plays, yeah, go ahead and continue. You can see here when it plays, it will kind of overexert on the number when it's playing it. So watch, when it hits the 2, you can see the rest, well, it wasn't too bad there. But the rest of the servos usually bend, like right there. They overexert just a little bit. This is because the servo setup itself is, it's not too sturdy. So normally in a robot without any position feedback, the robot is made excessively strong to avoid any unwanted change in the position, but with our servo setup, you kind of get what you get. But because it's inaccurate, we have the number pressed down on the arm harder than is necessary in case the position changes. That way it won't ever miss hitting a number. It's better to overexert than not hit the number at all. But because of this, you can see here, if it's pressing the 8, we might actually get, instead of 8, maybe 88 or 888. So to fix that, all we do is just take the mod 8 of the input, and it places the number there. So yeah, that's pretty much it. You can see we're just playing the robot here. So, and we won. Thank you.